Hello, thank you for watching our channel. This tutorial will go over creating tests for components and data-driven development with components under React. So first of all, if you go to our website at componentcontrols.com, you'll see a step-by-step blog article, data-driven testing with React. And while creating this video, we'll go over the blog post as well. So first, let's review the component-driven development and the broader functional programming. They are both old and new concepts, but they're getting more popular nowadays. Both of those are intended to encapsulate in a single function or component without side effects some functionality or some building blocks for a web application. This article is mostly for React components, and in a future article we'll review how to create tests and do data-driven testing for functional programming, just pure functions. So in our development process, we recommend organizing your components in separate folders. Basically, you have the component file, you have the component tests, you have the component documentation file or stories, you have the data file, and then additionally you have a design assets folder where you can have images, screenshots of how the component should look, as well as some design notes in Markdown file. And then the snapshots folder where the snapshots are stored. In general, the main reason for not creating tests for each and every individual component is because it's time consuming. So this will stop many programmers from achieving a high test coverage percentage. And in this tutorial, we'll show step by step how to start a React component library and automatically create snapshot and accessibility tests. If you are in a hurry, you can jump straight to the final projects, and you can see there is 4. They are built either with Gatsby, Next.js, Webpack 5, and Webpack 4. You have the live application with the tests, and you can also go straight to the source code of the applications. So let's get started with Gatsby. First we'll create a folder and we'll initialize a project. Then we'll open the project in VS Code. Okay. So as you can see, there is a default package.json file that was created automatically with Yarn. Next, add some basic dependencies. Okay, so this is just a standard Gatsby project and the React dependencies, and then this is the component controls package that creates a Gatsby team that creates documentation websites. Next, we need to create a Gatsby config file in the main folder right there. And inside we'll configure our theme where the config folder is placed. So we'll need also to create this folder, and inside of it we'll create a configuration file. Basically, we will need to specify where should our documentation site look for documentation files or stories. Okay, so we'll add some scripts to start the project and to build the project. Basically, they're just running Gatsby. Now we'll go on to creating our first component. It will be created in a folder within the source subdirectories, and then we'll create a components subfolder. As we saw in the introduction, the goal is to create each component into their own folder. In this case, our component will be called the variant button. So we created this folder structure just to have our component library better organized. Next, we'll create the component itself, named variant button. So obviously the whole project is built with TypeScript for this example. Let's have a look at this component. We import React, and then we have a couple of variants, primary accent disabled, and then different colors and background colors for the different variants. The properties, we see the text and the variant property. And then we create, by default, the variant is primary, and then we create a button, whether the disabled property is set with some other style properties, and then inside here we have the text with some padding. Once we have added the component, we'll create a documentation file or a story file. Basically, here we'll store all the examples of how we can use our component. Let's create this. Basically, you can see we are importing the button and the properties from the component file. The default export are just some conventions, and then we associate the component with the documentation file. And then here we have an example. Basically, it's a configurable example. It accepts some props, which in this case are the variant and the text. And then here in controls, we can specify some default values. At this point, you can also go and see further how to create the same example with Next.js or with Webpack. But here for us, we'll just start the documentation website. It's a standard Gatsby site, and as you can see, our documentation team is compiling the existing documentation files. In this case, a variant button.docs, .tsx. As soon as it's ready, we can go and see what we have so far. So there is already a lot of documentation that was generated automatically for the component. You can see the lines of code, the comments, a percentage, and then the library and the description of the component. And then here we have like an example how a user of your library can import the component. Here it's a playground where you can play with the component. Those are controls, again, where you can try different values for the component and see how they are rendered, or click on randomize and it will generate a set of random sorry, values. Additionally, you can see the external dependencies, and if there are any internal dependencies within the library, they'll be also visible. And then the component JSX3 for rendering. On the testing page, we also have some information. Here, this is light tests that are performed at runtime, and we can see there is a color contrast issue. We can select and see the affected component. In this case, it's the whole button. And then the viewport area, it's you can see in different screen resolutions how your component, since this button is fairly small, it will render even as a regular phone, etc. So let's go further from the article and now head into automated testing territory. So we'll add the component controls CLI tool. It's the one that will generate automatically test templates for the components in your library. Next, we'll need also to add jest packages and TypeScript related packages. In our case, we are using TypeScript for creating the tests. Now we'll need to configure Jest. We'll do it in package.json, but you can also create a Jest config file. Let's go here and add the Jest section to the of package.json. And create those test scripts. So now we can use the test create to create our test templates, and then test is just yarn jest, just running the tests as you would in any project. We'll need to configure TypeScript for just to be able to run the TypeScript tests. It's just a basic configuration. Of course, if your library is built on TypeScript and you will need to compile also all your components, you will need a more elaborate TypeScript configuration. Okay, and we are ready to actually create the test. We'll run the test create script and we'll observe what happens here. Okay, you can see there was a test file created. Basically, it imports all the examples from your documentation file and then creates the individual tests. It will create one snapshot test and then one accessibility using the Axe core testing, accessibility testing functionality. You'll notice this testing library example by default, and if we come here, we can see the W flag means to override the tests on each run. We are using it mostly because we want to play a little bit with the generated tests. And then the level at which we generate tests, we'll explain it in a little while, but there are different functions, different options that we can explore. So by default, we did the CC-CLI tool detected that this is a TypeScript component and it generated also the test as TypeScript. However, you can force the tool to create templates in a specific format with the F flag. In this case, it's CommonJS, but you can also specify ESM. So let's see now what it will generate. Okay, you can see now the test.js file, and it's a require, etc. So clearly it's not a TypeScript file anymore. We'll remove it. We don't really need it. We can also choose the renderer. As we saw, by default it was the testing library renderer, but it can also use the React test renderer or Enzyme. So let's create an example with Enzyme and run the test create again. We can even observe here the tests in real time. Okay, you can see Enzyme libraries are being used. So the whole test now is a little different. You would need to install those dependencies to your project if that's the intended use. Okay, let's undo those changes. We can choose also at what level to generate the tests. Here, there for each document, there is one test created. And we can see it imports it from the document. And this is the recommended way to create tests. However, if you want, you can also, instead of creating tests for each component and its documentation, you can have just one big test that is for your entire library. So this, instead of the doc, now it's at the store level. So let's run that one. You can see here it is generated into the test folder, and basically it's one that will go through your entire store of examples. Delete this as well. Next option is to, instead of the document level, to generate the tests for each story or each example individually. This allows to get full control and customize. Instead of having generic snapshot testing, you can generate clicks on the component and tell the test to verify specific DOM elements, their styles or text, etc. Let's run also this example now. Want to observe. Okay, so you can see how this is the example overview. In this case, there is only one example, but if there were multiple, there will be one after the other. And here you can see the individual snapshot tests that we had until now. So what we can do now is import the just DOM library. Those are just a set of custom matchers that we can use for custom tests. And then so for TypeScript, if we want to enable the matchers, we need this import here. And then here, that's what we'll do, and I'll explain. Instead of this snapshot tests, we'll replace it with a custom test. And you can see the guest test by ID, container. So first we have get test by ID label, and we can see that the test ID label, this is this div element, and then to have text content button, and then the container and the first children to have style background, again to have ATD, but this is the primary background or the default. So at this point, again, we can run the tests and see whether they are succeeding. Okay. It takes a little while, but yes, we can see the custom test was just executed. This was just an example, and at this point we'll revert back to our recommended document level test create. So this will be back to the snapshot tests. If we launch our yarn test, you'll see at this point the snapshot should be created. Okay, one snapshot written, here it is. And you can see the element itself. Okay, at this point we are ready to launch our documentation site again and to see, yarn start, and to see the difference that it made to have the testing added to our documentation site. So the big difference to remember here is that each component and each documentation page for a component will reflect the tests and the coverage specific to the component, not for the entire project. So maybe in our example here it doesn't make so much sense because there is only one component, but in a big library with dozens of components, you will be able to see the coverage for each one individually. Okay, let's see now what we've got. Okay, so those are the new here summary information, the number of past tests and the coverage. And we can see the test coverage by branches. So basically the lowest coverage is displayed here. Let's come here and see what we've got. We got those test results, the snapshot and the accessibility test, the time. And then we have the test coverage by lines, functions, statements, and branches. In this case, the branches are at 50%. Not all branches have been executed. Let's take a look at the code for the component. Here you can see this conditional if variant equal disabled, the property. So this is the one condition that was never executed in our tests, the disabled condition. To add an additional, let's say, test, in this case, we'll just go and add a new example. That will just be disabled. We'll not need any additional props to make it like a configurable example. And then here we'll say variant equal disabled, and then some text equal disabled, of course. Okay, so we made a change. You can see that automatically the tests have been run again, and actually the full snapshots will be executed again, the coverage will be executed based on the component. And we can see the user interface on your documentation site. It's in development mode, of course, and it was updated automatically. You can see some more test results. You have an additional snapshot and an additional accessibility test for disabled. And now the branches are at 100% because we added the new example that specifically tests for the disabled property. And again, if you go here, you can see the example, but also let's say we can go and just visit how does it look in a disabled state. So the beauty of it is it works both as a documentation tool and as a testing tool as well. Okay, let's remove now this additional example and continue. What do we have next is okay, let's review how errors are handled by so Okay, here we are back at only 2 tests, 50%. So now let's introduce a change to our component. Let's say somebody inadvertently makes 15 pixel padding. As soon as we save the file, you can see the hot module reloading kicks in and the tests are being re-executed. Let's go back here. At this point you can see now we have one failed test. This is the snapshot test that is failing. If we open it up, you can see the difference. The padding was 5 pixel, now it's 15 pixel. At this point you have two choices, either to revert the change so your test passes, or we can just delete the snapshot and basically this will signify that we are accepting the new values. As soon as we delete the snapshot, you'll notice again automatically the tests are being executed. The coverage will be executed and the new results will pop up into the user interface. You see now it is the test is passing. Sorry, with the new 15 pixels difference. Okay, so next is let's go into the data-driven testing. The data-driven testing refers to a testing method where there is only one test, but it can be fed with multiple rows of data. This saves on creating repetitive multiple tests while still offering a variety. The examples are multiple. For example, for a name, you want to test it with a huge name with a lot of characters. You want to test it with an empty name. You want to test it with some random names with spaces. You want to test it with some foreign accents from the keyboard, etc., etc. So also the beauty of data-driven testing is that the test data themselves they are stored in simple files of tables where a QA person can safely modify the data and add new tests without actually modifying the code of your unit tests. So to add data file generation, basically this flag, the D flag, and then the number after the D flag is the number of rows of data that we want to generate. The data is generated randomly, so if you want to keep some consistency, you can also specify the random data generator seed. So let's go back to our project. We don't need this. We need this, and then this is where we'll generate 5 rows of data with a seed. Okay, let's stop it and rerun test create. This will modify the test file and it will also generate a file of data. Again, you can see here the import of data and the multiple examples. So basically for each row of data it will run the tests once. Let's take a look at the table of data itself. You can see the row 1, 2, 3, 4, 5 and then text, variant, etc. So next we'll just start our documentation site and see the difference that it made, just the tests that we created. Of course, since the tests have been modified, now the project will be rerunning the tests, rerunning the coverage reports with the new data. And if we go back to our project, oops, almost there. Oops, okay. Okay, now let's see what we have here after we refresh the screen, of course. So those are the rows of data. Now we have them here in the user interface. Your users can use those as shortcuts just to see with the different data how the component will look. Additionally, you can see for each row of data, 1, 2, 3, etc., there is an individual test, both for snapshot and accessibility. And we have our test coverage. You can also modify your data. And here, let's say we just want to add a disabled state. You can see again the tests have been rerun. And they'll be reloaded here. Okay, here you can see the disabled data are added. Okay, so what's next? Yes, we changed that. Okay, generate new random data. Okay, it's gonna be fun. Let's go back to our editor and browser. We can use this, the randomized data functionality. Let's minimize this and look. Okay, so for example, we're like, oh, okay, that looks good. We want to save this set of data as in our data values file. Let's say we'll say row random. And then we just paste the data. Same thing, we have a rerun of the tests, and shortly they will appear in our user interface. Okay, 12 tests, and we can see our random tests at this point. Okay, that was all for this tutorial. If you have any feedback, please leave it in the comment section below. I would love to hear what you think about collecting tests, data, and other component assets in their own individual folders. Thank you.